This is similar to a lot of other ones where it says fill it in with less than or greater than or equal to. 27 doesn't equal 28. One of them is greater. So we're looking at pointing to the one that's less. 27 is less. This would be 27 less than, pointing to the left. Number 2, we got this 3-number set to add up. We've got 44, we got 452, and we've got 69. And what we do is line up the units at the decimal. Make sure that build to the left in each case. 2 and 4 make 6, 6 and 9 is 15. Bring 1 up here. 1 and 4 is 5, 5 more is 10, 16. Carry 1 up here. 565. Now subtraction can be tricky because we've got 32,553. Build this as 2981 from the right to left so you know where things line up. Don't guess where they go. Put the 2, then the 9, then the 8, then the 1. Now they're in the proper locations. 3 minus 2 is straight to 1. But 5 minus 9 will not happen. Take this 50, make it 40, and then 15 out of the 5. 15 minus 9 will be 6 for those that know. 1 more here is 10, 1 more there is 6. 16 minus 10 is 6. 4 minus 8, not going to happen. So we have to take the 24 and turn it into 10 and 14. 14 minus 8, for those who know, 6. 2 more on the 8, 2 more on that, it's going to get us 16 for minus 10 for 6. 1 minus 1 is going to be 0, and then we'll take the 3 that's unchanged, we'll get 30,661. Subtract 66 from 124. From. Focus on from. From is followed by where you start. Therefore, in this word problem, you cannot write the 66 first because you don't start at 66. You start at 124. From that, where you start, you take away the 66. And then you go ahead and do 4 minus 6. Not going to happen. Let's turn 20 into 10 and 14 out of the 4. 14 minus 6 can get you 8. 4 more here, 4 more there will get you 8. 11 minus 6 should get you 5, but if you wanted to, you can add 4 more here to get yourself up to 10, and 4 more there, 15. 15 minus 10 will get you to 58. The 1 has been consumed. We used it like 11 minus 6, 58 for your answer. Can't get negative 58 because you begin with the 124 as follows the word from. Okay, multiplication. I may have directed some of you already to Zetamac because you're going to need to know your math facts between 1 times 1 on up to 9 times 9. When you multiply a number by 10, you tack a 0 on the end, make it larger, by what we call an order of magnitude in base 10. Multiplying by 1, the number stays the same, so I don't know that too many of us need to work hard on memorizing those, but those are available as well. 6 times 9 is 54. The 4 goes in play, but the 50's got to float up here. 6 times 7 is 42. Pick up the 5 to get 47. No more digits to conquer here, so the whole 47 gets to go in there. 474 came from 6 times the 79. Now I have 70 times the 79. So I put a 0 in there, so that I'm going to start using it as a 70, not as a 7. It's in the proper location when it fills in beneath this 7. 7 times 9 is 63. So I will put the 3 in there, but the 6 from 63, 60 from 63 goes out here. Now I have to go 7 times 7 is 49. 49 plus 6 is 55. That makes 15 carries over. We got that. So we got, with no more digits to conquer, we're going to put the 55 right there. 4 and 0 is 4. 7 and 3 is 10. 1 from the 10 joins the 4 for 5. 5 and 5 is 10. 1 from the 10 that we just made gets us 6,004. Maybe it gets a little bigger. The more digits you have, the more columns you're going to have, and the more rows you're going to have. But here we go. 2 times 1 is 2. 2 times 8 is 16. I need to push the 10 over here from 16. 2 times 3 is 6. Pick up the 1 I had left hanging around, 7. Now 2 times 7 is 14 with no other columns to conquer. So that 2 alone made 14,762. Now I'm working on this 1 in the tens position, so I'm going to put a 0 there to make sure my work begins as a 10, not as a 1. Then I'm going to get the 1 times 1, 1 times 8, 1 times 3, 1 times 7. Now I'm starting on the 5 as 500, so I'm going to have to start in the hundreds place, so those are zeros. 5 times 1 is 5. 5 times 8 is 40, so I will put the 0 there, and 4 from 40. 5 times 3 is 15, pick up the old 4 from 19. 9 in play, but the 19 kicks its 10 over to here. 5 times 7 is 35. 35 plus 1 gets me 36. That second row was 73,810. This one is now going to be 3,690,500 from that 5. This other one is 5s again. So I have 3 zeros because it's starting as 5,000. But then it's going to be the 36905 is going to be there. I'm going to build it. Let me get the 5. Let me get the O, the 9, the 6, the 3. You see, 36905 in proper columns. 5 is still going to create those digits when it gets to work. 2 with all those zeros is 2. 6 and 1 with a couple of zeros is 7. 7 and 8 is 15. 5 more gets you 20. So I'm not just bringing up a 1, I'm bringing up a 2. 2 and 4 is 6, and 3 is 9, and 5 is 14. That brings 1 up here. 1 and 1 is 2. 2 with 7 is 9. 9 and 9 more is 18, which puts 1 up here. 1 and 7 and 9 will get me 16. You can see 1 and 9 make 10 with 6 more. So I again got to carry 1. 1 and 3 for 4. 4 and 6 for 10. Push 1 up here. And I've got that. Now I start to plop in my commas. This is units, tens, thousands, comma. And I got 1, 2, 3 for my thousands. I get here 4068 4072. We're going to do long division here. We'll stop when we get the remainder and we'll throw it over the divisor. And then that fraction might be reducible, but you want the full remainder when you're completing the work back to find your initial number. So what we have here is 4,861 divided by 15. 15 is right between 10 and 20. So when I look at this one, I know 4 can't divide by 15, but 40 has some 15s in it. I might see that as working maybe 3 times. And if it's too high, I'll come back and adjust it. 3 times 5 is 15. Gotta put my 1 there from the 10. 3 times 1 gets me 3. Pick up the 1 for 4. 45, that did work because it makes me have 3 left. 8 minus 5 is 3. The 4s are canceled, fully gone. Bring down the 6. I'm now dealing with 36. 36 does not have 3 of them in there. If you notice, 3 of them would get me 45. I'm going to go lower and go with 2. 2 times 5 is 10. Here's my 1 from the 10. 2 times 1 gets me 2 for 30. Okay, so now I have 6, and I'm able to bring down my 1. 61, I'm going to try a 4. I'm going higher than I did to get 45, so I'm going to go with my 4 here. 4 times 5 is 20. Here's my 2 from 20. 4 times 1 picks it up and gets you 60. So you got 1 left. Therefore, I have 1 over 15, because I'm 1 step past the last full cycle, which was when I had 324 15 times. I have 15 times 324 is supposed to get me almost to there. I need 1 more to get there. Let's see what happens when we check with our multiplication. 5 times 4 is 20. There's your 2. 5 times 2 is 10, make it 12. Put the 2 down from the 12, we get that one. 5 times 3 is 15, making 16. No more columns to conquer. This other one has a 0 here, so that my 1 functions as a 10, and then it's 1 times 4 times 2 times 3. We'll add these up. That's a 0. That's a 6. That's an 8, and that's a 4. What I had was a remainder of 1, so if I add that 1 extra 1 back in, I get 4861. This should be what I started with. You need the whole remainder to get added on to what the groups get you, right? Each group is going to get you a cluster of 15 steps. You did 324 times, you got all those steps together, and then you took 1 more step to start your next cycle. Here we go. 35, 26 divided by 43. Okay, 3 cannot divide by 40, not even close. 35 is close but misses. 35 is not as big as 43. So now I'm going to go for 352, and I'm going to put my first digit right over here. Now that's a 4. And I'm thinking of 35 divided by 4. 36 is 4 times 9, so there's no way 9 is going to work. I'll give 8 a shot. Maybe I'm wrong, though. Let's see. 8 times 3 is 24. Got my 2 over here. 8 times 4 is 32. Add on 34. Okay, that looks good. Let's see what happens. 2 minus 4 is not going to happen, so I've got to turn my 50 into 40 and make that a 12. 12 minus 4 if you know it. 6 more there, 6 more there will tell me that I get 8. 12 minus 4 will get me 8. 34 minus 34 gives me nothing else to work with here. 6 comes on down. 8 divided by 4 makes me think of a 2. 2 times 3 is 6. 2 times 4 is 8. That actually has a 0 remainder. So I'm done with right on 82 and no remainder. Therefore, if I take the 82 that I just found and the other thing I multiply by or with is 43. 3 times 2 is 6. 3 times 8 is 24 with no more columns to conquer. Now I've got my 0 to make sure my 4 functions as a 40. 4 times 2 is 8. 4 times 8 is 32. 6 and 0 is 6. 4 and 8 is 12. Carry the 1 over to make 35. To make 5 rather, and then when I make the 5 I don't bring anything over. 3526 should be what I started with. This is my 3526. No remainder to bring me into the next cycle. 868 divided by 22. Okay, we'll see. Maybe we get a remainder, maybe we don't. We'll go with this. 8 is too small. 86 probably has maybe 4. Maybe it's got 4 of these in there. So I go 4 times 2 is 8. 4 times 2 is 8. 88. So I'm not stupid. I have my moments, but the idea here is 88 was too big to take away. Therefore, 4 was too big to try to use. So erasers are not marks of being dumb. Erasers are tools of science that we work with the information we have and we go back and adjust it for our next attempt. So now I'll go 3 times 2 for 6 and 3 times 2 for 6. Now I'll see that that's a 0 and that's a 2. 20 is smaller than 22. Positive, so that's good with the 3 right there in the tens position. Now I'm thinking, if I got that close to being perfect, I might give 9 a shot. 9 times 2 is 18. Carry the 1 out here from the 18 is 10. 9 times 2 is going to get me another 18. Sorry, I forgot to bring down my 8. But 9 times 2 is going to get me 18. The 1 is here. 9 times 2 is going to get me 18, creating 19. 8 minus 8 is 0. Can't do 0 minus 9, so I have to turn this into a 10 and 10. 10 minus 9 is 1. I have 10 left over. Normally, in the olden days, you'd write R10. What we'll write here instead is 10 over 22. That's actually 39. These are both divisible by 2. 10, smaller number, divides by 1, 2, 5, and 10. 22 won't divide by 10, doesn't end in a 0. 22 won't divide by 5 because it also doesn't divide by 5, doesn't end in a 5. But it does divide by 2. So when we divide the 10 by 2, we get a 5. When we divide the 22 by 2, we get 11. There's our answer. But to get the remainder to work the job right, we have to take our 22 times 39. There's going to be a remainder to work with. 2 times 9 is 18. There's the 1 from 18. 2 times 3 is 6, making 7, and there it is. That's the 2 times 39. Now I got 20 times 39, which means we can do the same thing, but starting in the tens place instead of the ones place. 8 and 0 is 8. 7 and 8 is 15. Carry the 1. You get 858. The remainder is 10 more. I don't go here and grab the 5 out of 11. I need the full remainder of 10 steps out of 22. So I'm going to add my 10 steps back and get 868. And see that that is the number that I was beginning with. Dividing 6 into 102. It comes to as a word problem. Some people start seeing letters in math and they start to freak out. They say, this is a math class, I shouldn't have to do it. I know word problems are a little tougher, but we're looking through this and deciding what we have to do. It involves division, it involves 102, and it involves 6. This is going into the 102. So the 102 is what we're actually beginning with when we're dividing by the 6. We would say divide 102 by 6, or divide 6 into 102, 102. Now, when we look at this, we can't divide 1 by 6, so we begin in the tens location, the tens column. When we have a single occurrence of 6, 1 times 6 is 6, creating 4, bring down the 2 to complete a new number to work on, 42 still to be handled as part of the division. 42 divided by 6 is 7, so if we take 7 times 6, we'll get 42, and we'll see that the remainder is 0. Therefore, the quotient, the answer, is 17. We don't have any remainder or fractional or decimal part, so that's the whole bit of it. Now, if I were to take 6 times 17, I should see that it gets me back to 102. 6 times 7 is 42, there's the 4. 6 times 1 is the 6, pick it up for 10. No further columns to conquer, so it does make the 102 we started with. There's the quotient, the result of division, 17. Round 7846, that is 46. So where the 800 is might stay 800, might go up to 900. It depends what goes on behind the 800 digit right there, the 8s. So now we look at 7846, and the 8 might change. So we circle a look at the 84, and we are absolutely not worried about what's going on behind the 4. So we take our 7 and leave that out, and we turn our number behind the green's blob to 0. 84, is that more like 90, or is that like 80? 80 or 90? And 84 is not high enough to give me 90, so I'm going to go with 80. And therefore I get 7,800. It would have to reach 50 behind the 800. Right at 50, it turns up with rounding to make it into 7,900. And we got close, but we didn't get there. Convert 68 into expanded form. This is the number 6, and this is the number 8. And now what is this? This is 6 tens. That's 6 bundles of 10. Each 10 creates a click in the column where we're counting our tens, and that's 60 total, and 8 individual ones, which are called units. So it's 6 tens and 8 units, and that makes up 68. Should it go further out, it would be hundreds, thousands, and so forth, up and up and up. But that is what 68 breaks down to in expanded form.